Thank you for giving me the opportunity to present my undergraduate dissertation. The title for my dissertation is The Effect of Immigration on UK House Prices. My name is Lewis Foley, and this is my presentation. Chapter 1, Research Background. Introduction. As you can see from the diagrams, the average UK house price has increased by nearly 40% over the past 10 years, and this figure continues to grow. Within the UK, London continues to have the highest average house price, and the average cost of a property in London is £470,000, which is almost double the average price of a house in the UK, which is averaged at £290,000. The UK labour force reveals that the London boroughs Kensington and Chelsea, which have the highest average house price, are where the population accounts for a high percentage of immigrants. Within the same time frame, the number of registered immigrants in the UK has increased from 6,388,000 in 2010 to 8,320,000 in 2019. According to the property buying service Goodmove, UK house prices are expected to rise by an astounding 17% over the next decade. And according to the ONS website, a further 5.4 million people are expected to immigrate long-term into the UK over the next decade. After the Brexit vote in 2016, immigration has been a heavily debated topic in the UK, as it appeared to be the driving force behind the UK's decision to leave the European Union. And in general, I believe the word immigration has a truly unfair connotation. For example, I've seen on the news people claim that the jobs are becoming under threat from higher skilled immigrants, and therefore I wanted to create a model that was able to determine the real effect of immigration on house prices. Especially as most of the literature studies I reviewed were based in different countries, and this is why I believe it would be interesting to do it in the UK, and this is where I live. Furthermore, I believe that this topic is not only interesting, but also very important as a student who is looking to look for a house once I come out of university. Not only is it valuable to me, but it should be important to everyone else, as at every point in someone's life, they will try to move out and buy their own house. Although the state of the economy has a big effect on house prices, there are still other variables that can influence the change in price. My research aims to determine whether the stock of immigrants over population, socio-economic variables, demographic variables, and dependent variables significantly affect the house prices in the UK. In this slide, I will show the hypothesis tests that I will be testing. In the literature, SIZE conducted research and found that a 1% increase in immigration flows into the US correlated with a 3.4% increase in average house prices. Thus, his findings conclude that immigration does have a positive effect on house prices. However, other studies have found that immigration has a negative effect on house prices, and therefore the answer to the question is ambiguous. Furthermore, according to economic theory, the fundamental understanding of supply and demand, an increase in supply causes an increase in demand, which pushes up prices. As a result, the first hypothesis will investigate whether the number of immigrants divided by the initial population has a significant effect on the rise in house prices in the United Kingdom. Secondly, SIZE and Batcher discovered that in areas with higher crime rates, house prices are lower. However, Bell and his colleagues discovered that local authorities with high crime rates are not densely populated with immigrants, implying that there is no significant link between immigrants and crime. They also predict that local authorities with a high unemployment rate would have lower house prices because the local population cannot afford to live in wealthy areas. This study will investigate the second hypothesis by taking into consideration socio-economic factors. The experiment used by SIZE and Batcher discovered a negative correlation between house prices and immigration in areas where immigrants are less educated, prompting me to investigate whether local authorities with higher education institutions have higher house prices. Because jobs in higher education institutions tend to be well paid, I believe that demographic variables will have a significant impact on house prices, and this is my hypothesis 3. My final hypothesis will test whether inflation, a time-dependent variable, has the greatest impact on house prices. I predict that when inflation rises, house prices will also increase. This is because when inflation rises, the value of money is eroded as the purchasing power decreases. These are my 4 hypotheses that I want to test. Chapter 2, the methodology. This is the model I produced. The log of house prices is the dependent variable in my model. I chose to put the house prices into log form as this is a convenient way of transferring the highly skewed variables into a more normalized dataset. Whilst the stock of immigrants divided by the initial population in the previous period, socio-economic variables, demographic variable, and the time-dependent variable are the independent variables in my model. The lagged unemployment rate, lagged benefits rate, lagged crime rate, and the dwelling stock divided by the initial population in the previous year are the socio-economic variables in my model. To reduce the possibility of endogeneity between the variables and migration, I chose to lag the variables by 1 year. By reducing endogeneity, in my model, the independent variables will be less correlated with the error term, and thus the results will be more accurate. The number of higher education institutions in each local authority was tested as a demographic variable, and the inflation rate in the UK over the last 10 years was used as a time-dependent variable. These final two variables were used to examine how house prices can change, when only time series and cross-sectional data were used. Quantitative data for the model came primarily from the ONS Statistics website, but it also came from the gov.uk website. I chose these websites because I thought they would provide the most useful and accurate information for the data that I needed. The data set was created from 289 local authorities across England and Wales from years 2010 to 2019. I used cross-sectional data at the local authority level because the more observations I had, the more generalizable it is to the wider population. I also used time series data from the past 10 years, and by comparing the two datasets, I created an unbalanced panel data. However, it is unbalanced as I was unable to find data for the crime rate and dwelling stock in the years 2010 to 2015. Pearson's correlation analysis. Correlation coefficients are used to measure the strength of the relationship between two variables. The majority of the variables in this table have a strong correlation. According to the correlation analysis, the number with 2 stars next to them show a significant correlation at the 5% level, whilst the number with 1 star next to them show a significant correlation at the 1% level. However, some of the results in the red circle show no significant correlation between two variables, and some even show no correlation at all, such as the number of higher education institutions and the inflation rate, which is understandable. A circle has been drawn around the variables that have no significant correlation between them. The multicollinearity test. This test was done to see if there was any correlation between independent variables in my regression model. When the variance inflation factor, or VIF, is less than 10, or the tolerance value is greater than 0.1, the model is said to be free of multicollinearity. Multicollinearity is a problem because it undermines the statistical significance of an independent variable. As you can see from my table, both the lagged benefits and the lagged unemployment rate are above 10, suggesting multicollinearity. You'd expect this as people who are unemployed tend to apply for benefits to receive an income. Therefore, I removed the variable lagged benefits rate because there was multicollinearity between two variables. I chose to remove this variable over the lagged unemployment rate because I have more time series data for the unemployment rate, and thus additional information results in more precise estimates for this variable. There is no multicollinearity in this model now that the lagged benefits rate variable has been removed. Chapter 3, Findings. In this section, I'm going to present the regression results and draw a conclusion on the 4 main hypotheses that were mentioned earlier in my presentation. This table shows that the stock of immigrants to the initial population in the previous year has a positive beta coefficient and a significant level of 0.000, which falls below our 5% level. The adjusted R-squared also shows that the variable is positively related to the log of house prices by 17%. Thus, the regression analyzes that there is a positive and significant relationship between the stock of immigrants per population and log house prices. Therefore, hypothesis 1 is accepted. The lagged unemployment rate has a negative coefficient and a significant level of 0.000 in the table, indicating a highly significant relationship with the dependent variable. However, both the lagged crime rate and the dwelling stock divided by the population are both insignificant on log house prices. Thus, we cannot use their coefficients to determine the effects of these variables having log house prices. Therefore, we reject the null hypothesis that all the socio-economic variables significantly affect log house prices. The demographic variable, higher education institutions, has a negative coefficient and a significant level of 0.01. This displays that this is a highly significant with log house prices. Yet, the adjusted R-squared shows that the variable is only positively rated to the log of house prices by 0.002%, which is very small. Hypothesis 3 is still accepted as higher education does significantly affect log house price. The adjusted R-squared in this simple linear regression shows that the time-dependent variable is 1% positively related to the log of house price rate. So, with a negative coefficient and a significant value of 0.000, we can conclude that the inflation rate and log of house prices has a negative and significant relationship. The fourth hypothesis is also accepted. This slide displays the results of my regression analysis. The final goal was to run a regression to see which variable has an impact on log house prices. My regression model is a panel data fixed effects regression with standard errors clustered at the local authority level. I ran a test in Stata to see if I should use a fixed or random effects model, as well as autocorrelation and heteroscedasticity tests and an F-test. The results of the Hausman test indicated that I should use a fixed effects model instead of a random effects model. Following that, I used a Waldrich test to check for autocorrelation and a modified Wald test to check for heteroscedasticity in the model. There was autocorrelation in my model, but no heteroscedasticity according to the results. Furthermore, because my standard errors were cross-sectional, I needed to perform cross-sectional robustness for heteroscedasticity and cross-sectional robustness for two-time dependence within each local authority, which I accomplished by clustering the standard errors at each local authority level. By doing so, I was able to gather all of the necessary data and run the regression. Looking at the results, all of the variables had a p-value of 0.000, indicating that they could all fit into the model. In summary, the coefficient of immigration over population is only 0.002, indicating that immigration does have a significant impact on house prices. However, if we increase the stock of immigrants by 10 units, it would only lead to a 0.02% increase in log house prices, whilst holding all other independent variables constant. As you can see from the model, the number of people unemployed in the local authority had the greatest impact on log house prices. It shows that if the number of unemployed people is increased by 1 unit, log house prices will fall by 6.2%. This is exactly what I expected, because unemployment rates should have a negative impact on log house prices, because areas with a large number of unemployed people would have less expensive properties than areas with employed people. In this regression, a 10-unit increase in inflation rate has a positive effect on house prices and increases house prices by 2.7%. This backs up the findings that an increase in inflation causes an increase in house prices. The most surprising finding for me was that the number of higher education institutions in a local authority has a negative impact on local house prices. Finally, at the local authority level, crime rate and housing stock have little impact on house prices. This isn't surprising because it's difficult to imagine how house prices and crime rates being linked, because robbers, buyers and sellers don't sit down and discuss house prices together. In conclusion, I believe that my model provided a good understanding of how the variables influenced house prices. However, there were a few flaws in my data. To begin with, it would have been preferable to have balanced panel data, which would have provided figures for all variables over the same time period, and this would have created a higher accuracy within the model. Furthermore, a few of my variables in the simple linear models were found to be insignificant, preventing me from using the coefficients to determine the impact on house prices. Running the various tests in Stata was extremely beneficial to me. Particularly the multicollinearity test, which eliminated a variable that was very similar to another variable I wanted to use in my model. This would have undermined the statistical significance of an independent variable. After reviewing the data, I've realized that I want to include an instrumental variable in regression to account for both observed and unobserved confounding effects, which I will look at in a future date. In order to improve my model, I'd like to include more demographic and time-dependent variables, as additional research could provide more information on the effects on house prices. There is a risk of an abnormality because only one variable is used in the demographic and time-dependent variables. So I think it is unfair to say that simply because the inflation rate increased house prices or the number of higher education institutions reduced house prices, that all the other variables would have the same impact. Thank you for listening to my presentation. I hope you enjoyed it and found it interesting.